Now we're going to use our skills with fractions and rational expressions to solve equations containing rational expressions, basically equations containing fractions. So this is really, really handy if you can understand how to find the LCD. When I look at this first equation, the first thing I make note of is that I have a whole number in there, right? So this number 1 is technically over 1. So I'm looking at my denominators, and I want to find the smallest multiple they have in common. So the first thing I'm going to do is I'm going to look at the numbers 3 and 6. Well, if you think about the multiples of 3, isn't 6 a multiple of 3? So for my LCD, it's going to be a 6. And then for my variables, I'm just going to take, if it's just like this, I would take the largest one I see, which is x. So the step says to multiply both sides now by that LCD. So what you're going to see me do is you're going to see me skip a step. Eventually, you're going to see me, instead of writing it like this, 6x times 6x times, I'm going to go ahead and for each of these fractions, I'm going to multiply them individually, because that's what you're going to do. If you multiply both sides, then that really means you're multiplying each term. And also remember, this is over 1, right? I don't think that that's necessary to see, but that's nice to remember. Because what I would do at this point is, after I multiply everything by 6x, I'm going to reduce. 3x goes into 6x 2 times. 6 goes into 6 1 time. So what I end up with is 5 times 2 plus 1 times 6x plus 7 times x. So 10 plus 6x equals 7x. Now my equation doesn't have fractions. Now I'm just solving a linear equation. I'm just trying to get x by itself. So in order to get x by itself on this particular problem, I would subtract x from both sides, 6x from both sides, because that's going to zero out here, and it's going to leave me with 10 equals x. And again, remember that's a 1x here, but we just don't write it. And so that would be my solution on a problem like that. So that's what these steps basically say. The next example is a little bit tougher if you look at what's going on with these denominators. So I have 1 over 2x minus 1 over x plus 1 equals, and then 3x, and then x plus 1 over 1. So basically what you're doing is you're trying to find something that you can multiply each of these by to get rid of all the denominators. And so the first thing I'm going to think about is my LCD. So I see a 2 in the denominator. Do I see a 2 anywhere else? No, so I need a 2. I see an x. I also see x over here, but this doesn't have, it only has one x in this one and one x in this one, so the most is 1x. Oops, where'd that come from? But before I do that, I'm going to look at this. You see the 3? I need a 3. There's not a 3 anywhere else, but the most I see a 3 in any of these denominators is once. So 2 times 3 times. I also have an x plus 1 here and here. I still only have at most one x plus 1 in any denominator. So this is my LCD. That's it. Again, remember, if you look at this arrangement, right, you've got your 2, I've got my 3, I've got x plus 1, I didn't mean to skip the x, but I've got x, right? Takes care of all the colors, oops, without going over. So there's my LCD. Now, when I multiply here, I like to leave my LCD written out, meaning when I multiply this by 2 times 3 times x plus 1. For that first fraction, I can see that the 2 and the x are going to cancel out with the 2 and the x down here. So that's going to leave me with, so again, this and this are going to cancel with this. So what I get when I simplify this first part is just 3, really 1, right? 1 times 3 times x plus 1. I'm not going to write the 1 though, because that's, I'm not going to write the 1 because that's not going to change anything, because 1 times 3 is still 3. And then we have minus x plus 1 with another 1 on top. So again, when I multiply here, 2 times 3 times x plus 1, it's the x plus 1 that cancels out, right? So this and, this and this are going to cancel out, leaving me with minus 2 times 3 times x. But what is 2 times 3 times x? Well, that's just 6x. And then equals, and of course, I never have enough room on these, 1 over 3x times x plus 1. And so here, when I multiply everything is going to cancel except for the 2. So here, if I look, all of this stuff here is all of that stuff here. So the only thing I would be left with is the number 2. And so now I've got an equation, no more variables. It just takes one shot of multiplying everything by the LCD, and you don't have variables anymore. I mean, you don't have fractions. You have variables. You don't have fractions anymore. Ugh. So I need to distribute. I need to combine my like terms. I need to subtract 3 from both sides, because this is a positive 3, right? So I have negative 3x equals negative 1. And so when I divide by negative 3, I get positive 1/3. One thing that you should always do when you're solving these equations, and I didn't do it on this first one up here, is you should always check that your solution can be plugged in for x. If I plug in a 10 here, it's not going to make that denominator 0, so I know that solution works. If I plug in 1/3, it's not going to make anything here 0. 2 times a third isn't 0. A third plus 1 isn't 0. 3 times 1/3 squared plus 3 times 1/3 isn't 0. And so that's something that you always want to check. All right. These just get better and better. All right, so here's one that I want you to notice that we can do something a little different on. Actually, no. This is one, though, where if you have A over B equals C over D, you can do cross multiplication. Not cross and smile, or A cross, but cross multiplication, when you have a fraction equal to a fraction. But if I were to do my LCD, I have x minus 1 that I need, and I also have x plus 1 that I need. So I need x minus 1, and I need x plus 1. So I need both of those. So again, what I'm going to do is I'm going to multiply each side by that LCD. So when I multiply this side, the x minus 1's cancel, leaving me with 1 times x plus 1, although that's kind of silly to write. And then over here, when I multiply times x minus 1, x plus 1, the x plus 1's cancel, leaving me with 2 times x minus 1. Now what I'm going to do is I'm going to distribute, so x plus 1 equals 2x minus 2. So in order to solve this, what I would do first is I would subtract x from both sides. And then after I subtract x from both sides, I would be left with 1 equals x minus 2. And then I would add 2 to both sides, and I would have my solution, 3 equals x. I can always check my answer. 1 over 3 minus 1, does that equal 2 over 3 plus 1? Well, yeah, that's 1 over 2 equals 2 over 4. And we know those 2 over 4 is a half, and a half is a half, so we know that works. All right. What? This is not as bad as it's going to be. The denominator here is really 3 plus a, 3 minus a. And so for my LCD, the most 3 plus a's I see is 1 in any one denominator, right? I see 1 here and 1 here, but I just need the most, which is 1. And then I see 3 minus a here and here, but the most I see is just 1. And by the way, guys, that was difference of squares, right? That's 3 squared minus a squared. And so it's that formula that we saw way back in the day. So, oops. So that was fun. I'm going to look at the first one, and the first denominator is going to cancel out completely because I'm going to be multiplying by both, 3a, or 3 plus a and 3 minus a. So those cancel out. Next I have plus 3 over 3 plus a. Well, when I multiply this by 3 plus a and 3 minus a, the 3 plus a's cancel, leaving me with 3 times 3 minus a. And then it equals 2 over 3 minus a. And again, when I multiply by that LCD, the 3 minus a's cancel out. So again, I'm going to go back through here to show you what just happened. These canceled out, leaving me with 19. And then, of course, I brought down my plus sign. These cancel out, leaving me with 3 times 3 minus a. Here, these cancel out, leaving me with 2 times 3 plus a. I just don't like doing too many of those cancel marks because it gets really, really messy. So we should be able at this point to see that when we have something like this, right, I should do it there, but if I have something like this, those are going to cancel out, leaving me with 2 plus 3a. And here, these are going to cancel out, leaving me with 3 times 3 minus a. And then here, these are both going to cancel out, leaving me with 19. Now I'm going to scroll away from that madness, and look what I have here. Again, these are the type of just linear equations that we should be fairly comfortable solving. So the first thing you want to do to simplify these is you want to combine like terms on both sides and distributive property. So I did the distributive property. Over here, I get 28 minus 3a equals 6 plus 2a. Now, what I might do, and I'm getting to the point where, guys, I'm just going to do this in one step. I'm going to, how do I want to show this? I'm going to add 3a to both sides so that all my letters will be on this side. But then I'm also going to subtract 6 from both sides so that all my numbers will be on the other side. So I end up with 22 equals 5a. So when I divide by 5, I get 22 over 5 equals a. And that's a perfectly okay answer. I mean, it doesn't look pretty, but it works. If you wanted this, if you don't like that, it's probably because I copied the problem down wrong. It's not a bad fix. It is just that this should have been 12. So if this had been a 12 here, look what would have happened. This would have been 12 and 12, and 12 plus 9 is 21, and 21 minus 6 is 15. And so now when I divide by 5, I actually get a nice number. I get 3. So I'm like, okay, so that's great. So I went through all this process. I ended up getting 3. Is everyone fine too with the dividing by 5 part, right? Because you want to just know what 1a is. And it feels like I should be good. But there's a problem here. If I look back at my original equation up here, right, look at this. If I plug in a 3, there's going to be a problem. So if I take my original equation, let me give myself some more space here. If I go to my original equation, which technically should have been 12 over 9 minus a squared plus 3 over 3 plus a equals, did I even do that one right? Yeah, 2 over 3 minus a. So if I try to plug this number in for a, so if I come back in here and everywhere I see an a, if I were to plug in 3. Now, of course, this was squared. Then I would get 12 over 9 minus 9 equals plus 3 over 6 equals 2 over 0. And really, 9 minus 9 is 0. So there's a problem here. This is a big problem. So what that means is, what this tells me is that there is no solution. There's no solution to that original equation, because when I tried to find the solution, I got a number that makes that denominator equal 0, so that's not going to work. So you always want to check. Which is why on the next page it says, as we can see from the previous example, it's important to check the proposed solution or solutions in the original equation. Let's see, how many more examples do we got here? 2 more examples, I think. Okay, 2 more examples. Again, I'm going to look at this problem. I'm going to look at it in terms of it being all nice and factored. So x plus 2, x plus 5, there's x plus 2, equals 1 over, I can factor out a 3, that would be x plus 2 minus 1 over x plus 5. So, if I look here, I see an x plus 2, so I need an x plus 2. I need an x plus 5, and I need a 3. And so if I use this as my LCD, everything will work. Could I cancel this out? Maybe, but let's just leave it in there. So if I take my factored form now, if I take this and multiply each one of these by my LCD, I don't know how that works. So I'm going to multiply this first one, 3 times x plus 2 times x plus 5. And so that's going to equal here. So what would happen is everything would cancel out, right? These would cancel out. The only thing that wouldn't cancel out would be the x plus 2 and the 3. Now you're going to want to put that in parentheses and make that 3 times x plus 2. And then equals, and then when I do the same thing over here, I'm going to erase that for a minute. When I do the same thing over here, 3 times x plus 2 times x plus 5, then the 3 and the x plus 2 will factor out, and then I'm just left with 1 times x plus 5, which again, I'm just going to write that as x plus 5. And then we have minus 1 over x plus 5, and so I'm going to try to cram that in there, 3 times x plus 2 times x plus 5. So again, this is what I'm going to be left with because the x plus 5s cancel out, and so that's going to be minus 3 times x plus 2. So I get 6x, or not 6x, 3x plus 2 equals x plus 5 minus 3x minus 6. So 3x plus 2 equals negative 2x minus 1. So now what I would do is, again, I'm going to do this in one step, guys, to save myself space and time. I would add 2x to both sides of my equal sign. The reason I'm doing that is that can zero out. And then I want to zero out the number over here, so I'm going to subtract 2 from both sides. And so I end up with 5x equals negative 3. And then if I divide both sides by 5, I get negative 3/5. Except for I made a mistake. It's easy. It's an easy fix. Yeah, 3x, that's not 3x plus 2, that's 3x plus 6. Who wasn't thinking right? Okay, 6. So that means I would have subtracted 6 from both sides. And so over here, I would have gotten negative 7. And so when I divide by 5, I would have gotten negative 7/5. Still a gross looking answer, but it'll work. The last one is going to be a little challenging because this equation has 3 variables, big R, R sub 1, and R sub 2. And when it wants me to solve the equation for R sub 1, that means it wants me to get R sub 1 by itself. And so since all of these are different, then that means my LCD is just going to be R times R sub 1 times R sub 2. So if I were to multiply my first one over here, then the R's would divide out, and I would be left with R1, R2. And then over here, if I do R, R1, R2, those would cancel out, and I would be left with R, R2. And then plus, if I were to multiply by my LCD, R, R1, R2, the R2s would cancel out, leaving me with R, R1. I don't know why I used black on that one. Now, if the goal is to get R1 by itself, then I'm going to subtract this over here so that I have all my R1s on the same side. So R1 minus R2 equals, and I'm going to subtract R1 from both sides. And so if I subtract those from both sides, I'm left with R1, R2 minus R1 equals R2. It's crazy. Now remember, my goal is to get R1 by itself. These aren't like terms, but what I can do is factor. They both have an R1. So if I factor out an R1, I would be left with R2 minus R. Of course, that equals. And so now, to solve for R1, all I need to do here is divide by R2 minus R, and I will have what I wanted. Yes, that's multiplication, guys. I will have what I wanted. I will have an equation that is R1 equals. And that has to do with electricity, something called resistance. So that's a physical science problem. With that, solving rational equations.